Hi, in today's video I have chosen this function f of x equal to exponential x. This is very simple function. It's a special case of exponential function. Exponential function is written on this form in general, okay? This is general expression of exponential function, okay? This is just special case of this one. Okay, this one equal what? Equal to exponential x natural log of a. Okay? This is the expression of this one. Now I have chosen a equal e. E is a number 2.71 and so on. If you plug this one into here, you will see exponential x natural log of a, which is e. Natural log of e is 1, right? So we have arrived to this one here. Okay? So let's move on to determine the domain range of this function. This is very clear. This function is defined on all real numbers x, okay? So for all x real number, this function, the domain range of this function is r or minus infinity plus infinity. So this is the same thing. So let's move on to calculate the limit at point minus infinity and plus infinity. The limit of x is approaching to plus infinity. The limit of exponential x is approaching to plus infinity, which is plus infinity, right? The limit of f of x is approaching to minus infinity. Okay? Minus infinity, which is minus infinity, which is 1 over exponential plus infinity, which is this one. 1 over plus infinity is 0. Okay? Now let's move on to calculate the limit f of x over x. X is approaching to plus infinity. So this one is a limit exponential x over x. X is approaching to plus infinity. This is indeterminate form, 0. This is this type 0 over 0. In this case, I can apply the opposite rule to calculate the limit. So the limit of exponential x over x is approaching to plus infinity. The opposite rule, the derivative function of this function exponential x over derivative function of x, okay? So is equal plus infinity over 1, which is plus infinity, okay? Now for all x is a real number, f continues and derivatives function on real numbers, okay? So now I'm calculating now the derivative function. Let's move on to calculate the first derivative function of this function. We have f of x equal to exponential x. So f of prime of x equal to exponential x. It's the same thing with the second derivative function and third derivative function and so on until I get the last order, okay? All those derivative functions are the same as original function, okay? So now this function is positive function, so f prime of x is a positive function. Let's move on to variation table, where I can see the sign of f prime of x and the direction of the function as well, okay? So the first line represents x input points, the second line represents f prime of x, the third line represent f of x. Okay, now which is the sign of f prime of x? The function is strictly superior than 0, which is positive. Okay, our function is increasing. Okay, this sign, okay, determines the direction of the function. If this sign is positive, that means the function is increasing on this interval. If the f prime of x is negative, that means the function is decreasing on this interval. That's the role of to determine the sign of f prime of x. Okay, now what's left? The limit. We already calculate the limit at the point minus infinity, which is 0. So the function starts coming from 0 and up and going up. Okay, so the plus infinity is a plus infinity. I can calculate the output point of 0, which is 1, right? F of 0 exponential to 0, which is 1. Okay, so the point is 1 here. So as you see here, this information is telling us this function is positive for all x. Okay, so now let's move on to the graph where we can put our function. Okay, so now let's move on to the graph. So as you see here at the table, you see the function is increasing from 0 to plus infinity. Okay, on this interval from minus infinity to plus infinity. It's coming from this way and keep coming and crossing the vertical axis at the point here 1. So this one is 0, 1 here and keep coming up. Okay, the limit, for example, f of x over x is approaching to plus infinity, equal finite limit, equal the constant. So this one, if you put this one in the graph, it's going like this. Okay, so that's mean the function going towards this one. But in this case, we have f of x, the limit of x over x is at plus infinity. But that's mean the function is going towards infinity. Okay, that's the reason why I'm calculating this one. Okay, this is the good place where I can stop. Don't forget to support us by subscribing. Thank you for watching. I will see you in next video. Bye.